Hello and good morning. My name is Zulkifli from 3 Bank S3. Would like to explain about the coding of Lab 4 Discrete Fourier Transform DFT. For forward DFT, the function DFT EQN is defined as function to determine the DFT. In this section, the value of small and k variables were assigned and function of xk is computed. Then, to determine the DFT, the value of x1 to x4 is assigned, which then become variable of DFT EQN as in line 14 to 17. Value of x1 to x4 is assigned and become dependent variable for DFT EQN. The result of command window shown the null value of ones. The magnitude plot is also shown the value of null value of 1. Moving on to inverse DFT, function IDFT EQN was defined as function in order to evaluate IDFT. The value of k and n was set as in line 3 and 5, and value of x, function of xn, is set as in line 6. Like forward DFT, value of x1 to x4 were assigned, which then became dependent variable of DFT. The procedure is repeated from direct DFT, but later the value of IDFT is determined based on forward DFT and n value. This command is shown from line 30 to 33. The command window result shown that the value of A, which is equal to null value of 1. Next, in order to determine the matrix of DFT, function DFT matrix n is used. Like previous example, the value of k and capital N is set. The matrix representation of DFT is written as command in line 13, 25, and 38. The DFT matrix of DFT obtained in command window and graph is (1 by 9) matrix, which is consistent with forward DFT result previously. IDFT matrix is the inverse function of DFT in matrix representation. IDFT matrix N is used to define the IDFT. The product of matrix A and B, which represent DFT and IDFT respectively, produce matrix B orthogonal and prove that it was inverse exists. Last but not least, FFT(x) is a function built in MATLAB to determine the FT. We can either use this function or defining desired function like previous example. Like direct DFT, the value of x1 to x4 were assigned, which then become dependent variable of function FFT(x). The output produces 9 values of 1, which is consistent with direct DFT result in first section. That's all from me. Thank you.